Solving a system of linear and quadratic equations. The first equation is quadratic, 3x squared plus 2. That's a U-shaped graph that's opening up. The second equation here is linear. This is actually in standard form. 9x plus y is equal to negative 4, or you could call it a times x plus b times y is equal to c. That's what we mean by standard form, where capital A is greater than 0. That's not very important. The idea right now is to find the point of intersections of these two graphs without actually having to graph them. So there's really two equations here, and we're trying to find when do the x values, x and y values, satisfy both equations simultaneously. Why don't we use the substitution method to do this? I'm going to go ahead and label this as equation 1 and the second equation as equation 2. We're going to sub 1 into 2. And what do I mean by that? Every time you see a y, you're going to write, every time you see a y in equation 2, you're going to write parentheses 3x squared plus 2. Right? Whenever we write our substitution, usually indicated with parentheses to substitute that quantity. Now we could simplify this. Notice there's an invisible 1 in front of those parentheses, so you could distribute this invisible 1 and the parentheses drop off right away. So we get 3x squared plus 9x plus 2 is equal to negative 4. And now this looks like a classic problem that you probably have done in algebra many times, maybe even hundreds of times. And why don't we try to factor this? We could use the trial and check method. Some of you might like to use the diamond method or the AC method. I'm a big fan of trial and check, as long as you are playing with these letters or numbers correctly. So we need to make a positive 9 there. Well, this doesn't factor. And why doesn't it factor? Well, can you figure out there's a mistake in the procedure? So that's why this is not factoring. I could have tried the quadratic formula, but the more I look at this, I realize there is a mistake. And the mistake is right here. This shouldn't be a subtract 2. This should be a positive 6 or a plus 6. So why don't we fix that? That should be a plus 6. And let's, of course, take our handy dandy eraser and clear that out. And now we have a quadratic equation, but every term has a 3 in it. So make sure you know how to factor. Let's take out the greatest common factor, which is 3. And we have x squared plus 3x plus 2 equals 0. And then we have 3 times x. Let's say x plus 2 and then x plus 1. I've checked my factoring. There are 3 factors here. Obviously 3 is not equal to 0. But we do get x equals to negative 2 and x equals negative 1. Make sure you remember to write equals 0 on the previous line. Make sure you write that equals 0. This problem is really about equations. So you're going to write a lot of equations. Now we're going to go back and substitute. We're going to substitute and try to find y. So we're going to use equation 1. Equation 1 to find y. So let's say for x equals negative 2. We're now going to use a substitution method. So y is equal to 3 times the quantity negative 2 squared plus 2. So what is our y value? That's going to be 14. What about the other x value? For x equals negative 1, we're still going to use equation 1. And we're once again going to use a substitution method. So y is equal to 3 times what? Negative 1 squared plus 2. And that is 5. So what does our final answer look like? Our final answer is actually going to be a solution set with two ordered pairs. The first ordered pair, it doesn't matter here, there's no order to this. But let's say I'm going to list the first ordered pair as -2, 14. And let's list the second ordered pair as well. We need parentheses. -1, 5. And then close it with a set brace. So this is a set that consists of two solutions or two ordered pairs. Circle your final answer. Make sure you show all your work nice and neat, and sort of just react to these algebra problems.